Hi guys, it's my first time in front of you, so I'm very proud of it. So my first TED talk will be, I think, light, I think. So we are about to speak about making Windows great again. I have to say to you, it's not sponsored by Microsoft, okay? So you know that moment when you step into a modern building and boom, your phone signal just vanishes. You look at the non-existent Wi-Fi, or you can't access it. Then your LTE bars, and you realize even 5G or 4G can save you. We've blamed concrete insulation, bad cell planning, but what if the real villain was the Windows? Not these Windows, the Windows. These Windows. Okay? Okay, so today we are going to talk about how we can make Windows great again. Not just for Wi-Fi, but for GSM, 4G, 5G, with lasers. So, I'm Luc Pendic from France, owner at the company STEMC, and some non-important thing about me. Sometimes customers, or most of the times, customers' requests are sometimes out of scope. Please redo all my wireless infrastructure. See, it's 300 APs in a warehouse, but when you look at it, it's just 14 devices to change, maybe, not 300 APs. So, sometimes the best way to improve a network infrastructure is to look elsewhere. In glasses, we can have some simple examples: single glazing, double glazing, or low emissivity double glazing with coating, silver coating. You know what I mean? Silver coating, you will go up to minus 30 dB of loss, just with a very thin little coating of silver. Sorry. There is triple glazing too, so it's very poor again. We use this for modern building to prevent any loss of temperature, etc. So it's very common today for new buildings. But guess what? What does not go through the window too? Radio signal, energy. Okay. So we can lose, as I said, up to neg 30 plus dB of loss. So, for one of my clients, my customer in London, we use a solution. I'm not sponsored by Wave2 too, I have to say it. I have used their technology. So we use Wave2, which is a laser boat, not a boat, laser bot. Sorry for my English pronunciation. And it does like a grid. It engraves a grid with a size depending on the wavelength you want. Okay? So, yeah, it's a little video for you. Action. Okay, so the lasers will do a grid all over the window, all over the glass, to allow radio signal to go through. So like you see on this little design, we will recover like 25 dBs of signal, of intensity. So on this project, we were about to treat 140 square meters of glass, of wall glasses. And we had like, and we had like 22 dBs of gain between before and after. So I stole it for you, finally. Sorry for that. So like you know, wavelengths have known with formulas size. So you can choose the patch, the size of the patch you want, to do a physical filter for your own radio. So I did a small video with my iPhone trying to focus on this grid because it's likely invisible, except if you're here, if you're on the glass, seeing it. So you can see the grid after the treatment. And if you don't know the grid is here, you can see it. You will see over the window, not the window. Okay. So I can show you ground floors of this one because of confidentiality concerns, but you can reach to me if you want to see it with some particular data. I can show you also, the 4 ISPs, mobile ISPs, with previous engagements with different technologies, before and after. You can see here that we were like on O2, mainly on 3G, and after the treatment, we were about to go on 4G low. And yeah. Some other real measurement we did on this site, so up to 22 dB of improvement of LTE signal used for calling. And that's all for my presentation. Thank you, and see you later.